Hey guys, this is going to be our unit 7.8, and today we're going to be factoring trinomials that actually have this added coefficient of a. Okay, and so what we've been working on before is dealing with trinomials that have a coefficient of 1. But what if the coefficient is not 1? This is where we're going to find our next step. So let's go ahead and do our first example, just a refresher of how to go ahead and factor this trinomial. Okay, first thing we're going to do is find what the factors are of 45 and then see which factors of 45 add up to 14. So for 45, I have the number 5 and 9. And if I look at those two numbers, 5 and 9 do in fact add up to positive 14. So I'm already done. I found out what those two integers would be. So now I'm going to start by adding my x's to my binomials, and then we are going to keep the 5 and the 9. And we can go ahead and distribute to check our work. I'm not going to do that right now, but we know that 5 plus 9 is in fact 14, and 5 times 9 is in fact 45. Now, what if our a cannot be factored out by the greatest common factor? For an example, right here, we have an a as in our coefficient, but we know that we can factor, I'm sorry, we have a 2, but we know that we can factor it out because all of these other coefficients are divisible by 2. So what if I take that 2 out? Then I'm left with a squared plus a minus 12, right? And then I can go ahead and do what we've been doing before, where we would find what two numbers make negative 12 and multiply to make negative 12 and add up to positive 1. But in this case, we're going to have situations where we can't factor out anything. So we have to deal with how to make a binomial when we have that leading coefficient greater than 1. So we're going to be using the slip method. Okay, so when a cannot be factored out by the greatest common factor, we can possibly still factor the trinomial, and the steps below are going to show a method called slip and slide to factor the trinomials. So slip and slide is just, something that helps stick to your mind to remember kind of the steps of these, but we're going to slip a, right, this a right here, to the end of the trinomial and multiply by c. Then we're going to factor this new basic trinomial. Then we're going to divide your factor by the value you slipped over in step 1. Then we're going to reduce the fractions and slide any denominators next to the variable. Okay, so first step tells us to slip. So we're going to take this a or this 2 and slip it to the end of the fraction and multiply. Sorry, not the fraction, the trinomial. So we're going to take 2 and multiply by 3. So now it's going to cancel out that 2 by having x squared plus 5x plus now 6, right? 2 times 3 is 6. Then we are going to treat it like a normal trinomial, and we are going to factor into two binomials. I'm left with my x's first. We know that. And then what two numbers can I multiply to get 6 and add to get 5? Well, I know 2 times 3 is 6, positive 6, and if I add them, it's also positive 5. So now I have 2 and 3. Then my next step says to um, divide your factor by the value you slipped over, right? We just took this 2 and we slipped it to the 3. So now we're going to divide both factors by 2. So we are going to put this 3 over 2, put this 2 over 2. Then we're going to reduce our fractions. So now I have x plus 1. And then in this case, since it cannot be divided into a nice little fraction, this is where we would slide our 2 next to our x. So now I have 2x plus 3. And this is our final answer. And so we're going to go ahead and do a run through just to verify and make sure that everything looks good. 2 times 2x is going to be 2x squared. X times 3 is positive 3x. Then we have 1 times 2x, which is 2x, 1 times 3, which is 3. I'm going to combine my like terms. I have 5x plus 3 and bring down that 2x squared. It does, in fact, check out.